So yeah, for my slot in this, I wanted to talk about a couple of things. First of all, these are the uh, tutorials that I've prepared a bit. They ones that I want to talk about are especially this viewpoint about building dev-proof apps. This is something that's been on my mind a lot because um, yeah, as you'll see from all of the tutorials here, like the tooling and developer experience around building TE apps is really, improving a lot quite now. So it's for sure being really effective at making prototypes and very early stage things that can show the power of being able to work with confidential compute and work with remote attestations. But I'm really interested in like where the gap still is and what's difficult about finishing uh, TE applications that use the TE to their fullest potential. And this notion of DevProof keeps coming up, especially because I'm used to auditing things from a security point of view, and I'm now starting to think about the real goal of TEEs as DevProofness. And it's really kind of distinct from thinking about security because it's really about a DevProof app is all about proving that the developer, the insiders, don't really have any privileged position. And that's a little bit different than the viewpoint about security auditing and systems where it's really about outside attackers. And so I'll talk a little bit about how I think about that and point out some pitfalls that are where applications running on TEs today still haven't quite filled that gap. And the context of this is all of my tutorials are kind of geared towards helping you close all of those gaps and have dev proofness to its fullest effect. Um, this little overall schematic that I'll talk about is kind of, I guess I would say that this reflects what I aspire for TEs to be able to do, which is essentially the fullest form of dev proofness, which is basically, I can backtrack a little. I think that smart contracts are the best instantiation of this dev proof concept. And the way that I think about what T's and especially these Docker composed frameworks, both the DStack one that Hung presented on, and you'll see Oasis Ruffle presented in a little bit. These are two different frameworks that are both Dockerized frameworks for making TEE apps. And I basically think that these containerized TEE apps are going to be the new form of smart contract, but otherwise they're going to have all of the really key properties that make smart contracts so interesting. And this dev proof property that makes smart contracts so interesting is really that it is about lowering the barrier to entry for innovative application developers. This is like that goal of decentralized and permissionless innovation because it's so easy to be an app developer composed with other people who are app developers, and all of you are able to get users to use this system in a trustworthy way, even though you as the application developer don't have to be a huge app developer team. You don't have to be a very well-established one. The whole point is that the application developer just has to write their code and make their code embodiment of whatever insights and special abilities they've developed um, without having to build a huge long-lasting reputation or too big to fail size in order to convince users to use them. So the application developer can write their code, but they don't have to be trusted by users because if they write smart contracts, the point is that users and auditors, anyone can see exactly what the code is, so you don't have to trust the application developer's word for it. You can just trust the code itself. You can check the code itself. It's the same thing when the app developers now publish these Docker Compose files. These Docker Compose files now define applications that use the confidential computability, but because the end users get to check the remote attestations, and even if the end users aren't going to look at the attestations themselves, because end users don't, the end users can tell that the attestations are there, that there's public evidence being generated by these applications, and auditors or other developers, anyone in the ecosystem gets to see these remote attestations and review them, talk about them in public, upvote them, or sound alarms and point out flaws where they're there. So, altogether, the point is that this is about lowering the barrier to entry for application developers by making it so that you don't have to trust them. Um, and that's this kind of full potential. I say full potential because as depicted here, it's like you just send the Docker Compose, just like publishing a smart contract. You just put it on a blockchain somewhere and don't worry about where it's run. It can be kind of the same thing if you write your application in a maximally decoupled way. If you just run the application yourself, like you rent a cloud node that has key capability and you put your application on there. Um, Basically, unless you have like a peer-to-peer replication way where other people could bring their own nodes even without you having to permit them, then at least the availability of your system might still depend on the dev. So, and then maybe make this a little more complicated, but the kind of relevant questions in the bottom left here are also what it means for DevProof to go wrong. Like the relevant questions are, first of all, if there's sensitive data or credentials or digital assets, is the application developer able to rug them? Like, can they peek at the sensitive data or repurpose the digital assets from, for themselves? The whole point of the DevProof design is to at least make this question answered, yes, the dev shouldn't be able to. And then a failure in that is something like an inadvertent backdoor left in where the developer would still be able to. And again, this isn't a security thing per se because it doesn't mean that there's a bad intent from the developer or even that there's a whole lot of risk, just that there's a gap in them, in the developer being able to prove that they can't. A second question is, even if regardless of whether the developer is entirely prevented from being able to misuse sensitive data, a common setting that we have is that the developer has some ability to upgrade code. And then the question is, can the developer prove that, even though they have the ability to upgrade some code, can they prove that they've never applied an update that is to some code that isn't safe or for which you don't have a proof that it's safe? And then the last thing, like I mentioned, is availability. So this is about, is the developer the only one with keys to run a node that can provide this app service? Or is there some sort of backup where even if the developer turns off all of his accounts and deletes all of their keys, the system still works? We're used to this in smart contracts on a blockchain, right? Like the deployer of a smart contract may or may not have some upgrade capability. Often even that is diffused as far as possible, like with a big token panel that has to approve updates. But in general, if the guy who created a smart contract and initially deployed it goes away, that's fine. The smart contract is still run, by the blockchain itself. So it's the same sort of goals you can have for maximally dev-proof T apps. So I mentioned that my interest is in clarifying this concept and helping get to the point where we can finish apps and judge them by this. So a couple of interesting data sorts that are a good source for going and look at these. I basically refresh this every so often and see if I can spot anything new. This is basically a public directory hosted by Phala of DStack applications that have opted into the public registry. And I think this only covers ones that are on Phala Cloud as opposed to any other DStack providers. But anyway, it's a public directory of these. Each one of them has a smart contract associated with it. That's like its control point. And they vary in terms of like what you can do next in terms of going and finding the code that generated each Docker Compose. This is for basically running instances of DStack nodes. This templates is another interesting directory that is basically sample Docker Compose files. Many of them are illustrating some sort of integration with an external service. A lot of them are just self-contained. And these aren't exactly one-to-one, but it's like a lot of the running instances that are listed in the public registry are also an instance of one of these templates. So the templates are like starter pack codes, these verified applications list. I think right now there's around 300 of them. Yeah, those are running instances, many of which are based on these templates. I have a little chart here, but I don't think it's super useful to go into a whole lot of detail, but it's like, these are the this isn't like one architecture, but sort of these are all of the components that are usually or optionally found in DStack applications. There's usually some split between a front end and back end. Often you want to have something that's like doing load balancing or is like a dashboard or other front end to your TE app, but you want to run that in Vercel or somewhere else that's outside of it. So you often like will look at how you break up your application into a TE component and a non-TE component. Sometimes you also just have the entire front end. It's like a front end website served directly off of the TE. Later you'll see a demo of Hermes. That's probably right now my favorite DStack launched application, and that just serves the front end directly from the TEE. So you'll see that, I think, in the example. Um, Maybe the only important thing on the left side is that there's two main kinds of clients that you typically have in TE applications. Ones that are proactively verifying. So like if you make an API server and you provide a custom remote attestation aware client, that kind of gives you the best security because then the client is actually checking remote attestations before doing any interaction with it. But often for more wide usability, you don't want to assume that the users are developer aware and installing custom clients. So instead, you often want to provide some front end to users who just have browsers, including plain browsers without even a proactive checking attestation. And you can still be getting some meaningful TE guarantee because of when it's conditional. It's basically based on the TLS certificate authority system, or even better, the certificate transparency system, which makes a public registry of all of these certificates that are ever issued for a domain. So if you want to build a TE app that's as secure as possible, but you want to have users that just have ordinary web browsers, what you would typically do is use this TE front end, serve your service from this domain, and then the guarantee that you might have is that all of the certificates ever issued for this domain, you can provide some evidence that there's a remote attestation that shows that this certificate originated from within a TE and never left it. I think I don't want to say anything more about the rest of these. Well, it'll come up as a pitfall in a second, but the green box here, I've kind of colored gray everything that is running in a TE, white every component that's not running in a TE, and then green is the smart contract, so publicly visible and immutable record that's there. And the role that the smart contracts play in most TE applications is that they are the coordination layer. Like if there are developer upgrades, then the smart contract will have a record for every upgrade that takes place. So the observability and permanence of the blockchains is used in these TE architectures because that's your go-to point for high availability coordination records. Okay, I may come back to one of these two architecture things if I think of something to explain, but what I had in mind now is just to go through a couple of 4 pitfalls that I've seen most commonly by trying to go audit the dev-proofness of these applications. So the first pitfall that I've seen a whole bunch is so you saw in Hung's demo where you can define your Docker Compose file. That's the basic unit of defining a T application, is defining a Docker Compose file. And you often want to have host secrets that you set, but that are not published. The best example of these are your API keys. You often want to be providing API keys of some kind to your T application, but obviously you don't want to publish those API keys as part of your open source code. So DStack provides this pass-through environment thing that turns into, at the time you launch your DStack application, you provide your API key, it gets encrypted, so only the TE can see it. It's not part of the open source code. So that's how you use these encrypted environment keys. The pitfall can happen when you put not just API keys, but also something that really should be part of the attestation, because you put something like in this example, it's like you put a base URL for the API that you're hitting. Having that as an encrypted environment variable is usually a mistake. the reason why it's a mistake is because the whole point of this is that it's not part of the open source attested code. So the host is allowed, or the app developer is allowed to set it to whatever they want. And if you set this base URL to whatever you want, well, it could point to any API, not just OpenAI, which is arguably an acceptable trust anchor, but the developer's own local cloud where they just output everything that's pasted there. So I don't know if I'm saying this in super clear, a concise way, but basically putting API keys as encrypted environment variables, that usually makes sense. Putting anything that changes the functionality and changes the trust surface of what your application does, that's usually a mistake. And again, what this turns into isn't a security vulnerability per se. It basically just becomes, a gap in the developer's set of evidence that proves that they don't have any access to sensitive user data. So it's not like an exploitable by outsiders attack, but it's a gap in the, open source attestation code. Base URL is usually a good choice to just hard code into the Docker Compose, and API key is usually a good choice to keep as encrypted environment variables. The second most common thing that I've seen is a misunderstanding of what the smart contracts give you. So even when using the Phala Cloud, there's a couple of choices of where your key manager goes. You can use a test or the Phala key manager, or you can use an Ethereum or Base. I think in principle, DStack works with any EVM compatible blockchain, but yeah, Phala Cloud supports Base and ETH for launching these. If you don't pick one of these and you use the default, which is just the Phala one, then what you don't get is this upgradability audit log. And what's neat about the upgrade, the smart contract based upgrade audit log is that you get a blockchain event emitted every time the developer or governance panel or whoever has the authority to upgrade a TE app, it emits a blockchain event that's a permanent record of which update was applied. And so this is how you define the audit surface. If you want to show that none of the upgrades ever deployed have, misused sensitive data or had unpatched bugs in them or so on, this log is basically what shows which versions of the application were allowed at any time. There's also compose hash headed and compose hash removed. So, you could also look at versions that have been expired and say do auditing only relative to some region. Anyway, the point to make here is actually just that the pitfall is failing to use this or not realizing that you have this ability available. If you don't use this, which I think is like, it's in the production checklists to, use this key manager, but it's I think a detail that a lot of people miss otherwise. Basically, you just don't get any audit log of an upgrade record. And then that means that the developer, as the application developer, you have no way to prove that you didn't do a malicious update when no one was looking, and then counteract it with a second update, because those updates aren't necessarily logged anywhere. You're not getting this audit log benefit that DStack is built to provide. Okay, the third pitfall, which is kind of closely related to this, it's also a thing that can go wrong when you have an application that you are updating, is to leave out some of the, to forget to make an archive or a backup of some data that's relevant for auditing these old versions. So what happens is that you might be updating your application a lot. You go through version 1, 2, and 3. Even if you use the audit log from before, this means you've got like the hash of version 1, the hash of version 2, and the hash of version 3 all logged on chain. So that's great. You've got a record of those hashes. But say you want to go do a retrospective audit. Someone who wasn't around during version 1 now wants to go and say, like, okay, well, did version 1 have any, misleading or leaking data code in it? You need to make sure that then you have to provide to this auditor kind of person everything you need to, finish checking the attestations. And in the case of DSec, this includes this TCB info, or basically the app compose file. That's kind of the key thing to check. And a lot of times this includes things that you might not remember, or that if you are storing them in an evidences thing, like in some metadata server that offers these, basically there is in DStack a default metadata service, this thing you find on 8090. It's like a great way for debugging and showing instance about your running applications. It has all of the information that you need to uh, uh, connect the Docker Compose file to the remote attestation certificates for this running instance. What you should do is basically, when you have this running instance, take a snapshot of it, or like a Internet Archive or something, back it up somewhere, because when you upgrade the machine, this 8090 will be replaced with something running the new version. So if you change your mind later, you won't be able to, all I'm saying is you won't be able to access this 8090 port for a machine that's already been, destroyed or upgraded to a new version. So the pitfall is just not doing this the way around. It's pretty simple as well. You just want to make the archive of it. The last couple of things that I want to talk about are really about interoperability. So I mostly talk on DStack because that's the one that I've spent the most time on. In this tutorial day, we'll hear from DStack as well as Oasis, which are basically complementary protocols. They're both instances of Docker-based containers applications that use smart contracts for coordination and observability, and are run specifically on TDX confidential virtual machines. And so something that I care a lot about is basically application interoperability between these. So I like the idea that applications should be nimble. They should be able to, in the same way you want smart contracts to be able to, move relatively easily across different blockchains. I think it's in the same case here. You would like your TE-based applications to be written in a fairly portable way. So something I care a lot about is being able to show ways of taking your application and making it so nodes in your application could be provided from many different networks. Anything that runs a TEE should, you should be able to include as possible node runners for your application if you want it to be as portable as possible. And one thing that I found is a useful way of explaining this and thinking about it comes from recognizing that GitHub actions actually are totally suitable as a TEE. This isn't like the thing that you should be using necessarily, but it's a really great way of explaining how to think in terms of attestation. And it also leads to a really compelling illustration of how you can go about providing interoperability to it. I won't go into too much detail into this, I think, because I'm only going to be sharing one tab at a time. I can switch easy enough between these. I have this demo which you might find interesting to play with, which is about using GitHub Actions as an on-chain compatible TEE. And what I mean by using it as a TEE, it's maybe not obvious that it has all of the features that you want, but basically GitHub Actions, okay, I'll give just a little bit of context of this. GitHub Actions is the system that runs continuous integration and continuous builds on GitHub. And it's pretty easy to use. Like, it's a free thing that every GitHub account has access to. Basically, if in your GitHub repo you put in .github/workflows some YAML files, each one of these YAML files is a script that can run under manual triggering, or even that can be attached to run automatically on like a time period or when issues are created, or as like a post hook on commit. And the point of it is that so these actions are programmable. They also have the same isolation feature that a TE does. So if these make like a random choice within them or have some intermediate values, you as even the account owner can't peek in or tamper with the programs while they're running. Like, you can't see the session keys when it makes a TLS query to download packages or visit a website. So it has the isolation property from TEEs. And then it also has this feature where you can get you can request a signature from GitHub's own certificate authority that gives you a little signed certificate that says, according to GitHub, this commit hash, which means the entire description of the script and everything in the repo, It's a certificate that says this commit hash produced this compiled binary as output, right? So maybe this is intended to be used for software signed program binaries, but you can use it for any output you want. So basically, it provides the same kind of remote attestation that what you ordinarily think of as TEEs like TDX give you. I've gone into more detail that I wanted about just this GitHub zk-TLS sort of provocative kind of TE because it's an unconventional one. But really the point that I wanted to make about this was interoperability. And the point that I want to make about interoperability is that if you're using smart contracts for coordination of TEs anyway, which you should, and which Ruffle and DStack and several others do, then that smart contract is also a good place where you can do interoperability. So the rest of what's contained in this example is basically this TEE bridge contract. Basically, it is a smart contract that just has an interface that can aggregate both of the other kinds of smart contracts for completely dissimilar TEE systems. So basically, there's one smart contract that recognizes the certificate format from GitHub Actions. It can process the signatures via a zero knowledge proof that GitHub produces, and it can say, this is the commit hash that produced this code, and the smart contract itself checks all of this for GitHub. There's also the smart contract that DStack is already provided with, which is basically the smart contract that defines how to verify a DStack signed certificate, which means it has like Intel's public key built into it the same way the GitHub one has GitHub's certificate public key built into it. And then this aggregator smart contract basically just carries out the list of allowed codes and configurations on the respective ones. But basically now what you can do is have a shared namespace, like a application private key that is shared between any of the DStack TEEs or any of the GitHub runner TEEs. If I added a third leg for Oasis here, it would be the same kind of thing. So this example is just an illustration of this pattern. I think the takeaway from it is that maybe this is the way that you can think about like why you might want to extend or build on top of the smart contract structure that DStack uses. You can use this basically to do your interoperability. So yeah, and the relevance to people in a hackathon is I think if you're thinking about how you would want your application to be able to be sort of future-proofed or able to hop around to different environments, or at least be able to have the largest number of backends possible. I think you should be thinking about the use of the smart contract layer as the way that you would implement your migration and portability that way. Yeah, okay, that was the exact right amount of time, and I think that's everything I wanted to say for this.